Okay, we're back at the Bridgeport here, and I have a customer who's putting disc brakes on a Chevrolet truck, and he's put a posi unit in the rear, and had to shorten his axle, I believe. He's putting a Wilwood brake kit on, and they came supplied with this type of spacer, I believe this is, and for his application, these were too wide. Um, these are measuring 0.589, I guess, somewhere in that range. Maybe 0.5890. Yeah. Anyway, so he's asked me to mill off 150 thousandths, 0.15 off the surface here. He only needs one. The other side he got to fit, and he was going to take a grinder to it and just grind off, but definitely on the Bridgeport, I think we can get a better surface finish and more uniform thickness. He's going to lose the anodizing, obviously, but he's okay with that. There is a part number, either cast or stamped into these parts, and so we'll go ahead and choose this side to remove the material so he can maintain this part number if he ever needs to look this up. So really the challenge here is, how do we hold this thing? If I was doing many, 10, 100, I'd probably design a fixture where maybe I picked up on these 3 locations, or I would do something unique, but I only have to do one. So one thing came to mind is the old awesome parallels, where I could sit in here and that would hold it at a height high enough, where I could machine my 150 off here and not have to do anything, not have to move the setup. And that's probably a good option. Although as you tighten the vise, because of the springiness here, it's going to try to open this up. And so you really can't tighten too much on the vise. I think you probably either bend or crack this or break it. And so I'm a little skeptical about doing that. I mean, one could put some type of a support here, some type of a bridge that would allow you to tighten up on the vise, and I may do that. I'm exploring my options right now. I mean, you can almost feel, I barely tighten on it, and you can almost see it flexing a little bit. So maybe not the best option. Other option is we could come right here on the table, and using clamps. Let's put the other side down. Using clamps, toe clamps, we could clamp this down in maybe 3 places, like that. I'm gonna put a T-nut in here. So maybe right where these bolt holes are, we could clamp this down, and then come in with our end mill. So I can find an end mill handy here. We could come in with our end mill and machine off everything except where the clamps are, obviously, and then move the clamps to another location that we've already machined, and then come and machine the spots we couldn't get to before. The only problem with that is a whole nother setup, right? There's probably going to be some type of a mismatch, which in this case is probably okay. I think that the tolerance on this is probably plus or minus 15 thousandths would be my guess, and maybe even more. But we want to try to get the numbers. We want to try to hit the numbers. So, kicking around some other ideas. Maybe we could hold it in one place, and then somehow support, capture this in here where it won't flex. I think if we just hold it in one place and we don't do anything on the ends, these might try to flex out on us. It is aluminum, so pretty forgiving. But I like to put a little thought into the setup, and because this is a pretty unique shape, I thought I would do a video on it. So let me scratch my head some more and see what I come up with, and I'll keep you guys posted. So just a little side note, something I normally do, but I think because I was on video, I took a short step. Always take my finger and clean the caliper surface here, and then kind of make sure they close correctly. When I was measuring it before, I don't think I was right on 0, and so now that the calipers are adjusted correctly, it looks like this is 0.588. If anybody's interested, or maybe 0.589. I don't know if that's, doesn't look like it's focusing, but you just have to take my word for it. Anyway, not that big a deal. So it's probably important that this piece is pretty uniformly on the thickness, pretty uniform thickness. And so I did just a quick measurement after I got it in the vise, and that's 225, and that's 215, and that's like 218. And so this isn't the most accurate way to measure. So because I'm not getting a number I really like, I went ahead and put a dial indicator in the spindle, and now I can drop this down and kind of walk it around and get a little better reading, I think. So let's go ahead and do that. And we'll just kind of put it here and then reset this to 0. Kind of loosey-goosey in there. This isn't your highest quality caliper. I'm sorry, dial indicator. Let's bring that back around so we can kind of see it. Okay, this is how I decided to fixture it. I put a piece of aluminum right in the center to carry some of the load and to help equalize the forces. So got an end mill chucked up, and let's go ahead and take a test cut. Oh, just for those of you who don't know, I am running 3-phase. I've got a variable frequency drive hooked up, so I'm able to run the stock 3-phase motor that came with the Bridgeport. I also run my lathe on a 3-phase, so I share the variable frequency drive. It's pretty rare that I need to run both of these, and so I just plug in as needed. So that works out pretty well. Okay. Get some lube going. Let's see what RPM we're at. We are cutting aluminum. Yeah, so that may be good. Kind of an odd shaped piece, so I'm trying to think if I want a conventional or column mill this. There's 0 minus a piece of paper. A piece of paper is about 3,000, but we're not going to worry about that at this point. So I think we'll take a test cut. Let's go ahead and take 30 thousandths, just for grams. See how this is going to cut. Get some safety glasses. Okay, we're down to our final pass. I'm getting ready to take a measurement so I know how much to cut off. And sometimes it doesn't feel like this one's too bad. You can get a little bit of a roll on the burr, and then you measure that thickness, and you're actually measuring the height of the burr. And then you make your cut, and then you deburr, and you miss your dimension. Again, not that this part is that critical, but it's good to stay in practice. And where'd the calipers go? There they are. So let's see where we're at. So looks like we're about 435 there. Again, I think I was measuring a little bit of a burr earlier. See if I can get over here and measure. So on this final cut, I like to use a WD. You probably should crank the RPMs up, but I've got my variable frequency drive maxed out, so I'd have to do some pulley, change the belt on the pulley, and I'm a little lazy for that. So we're just gonna take our 5,000s here. Go ahead and clear the shavings. Let that slow down or stop. This time we'll probably be able to measure the right hand side a little better. We can find a rag. We'll even wipe it down as we make this measurement, just to make sure we get a good measurement. We'll hit it with the file again. And we'll deburr this a little better after we get it out of the cut. But just for this measurement, we'll knock these burrs off. Just want to make sure this thing is pretty parallel and the right size, of course. So we're looking for 430. Let's see where we're at. So about 431 on that side. Which is good enough for me. Let's see what we're at the other side. Again, remember we had plus or minus 15, I think, on this one. So. I know, right 430 on the money. So I think we're going to go ahead and take that out. Well, wasn't that tight? Our little spacer worked out really well. We didn't have to move it around. So that came out pretty good, I think. One of these days I'm going to organize this garage and quit tripping over stuff. So that's what the original looked like. Here's the modified. Surface finish is pretty good. Now we can really measure it. I mean, we could have pulled the mics out, but that looks like 430 on that side. Oh, 430 on that side. Once we get these burrs off, I think we're going to have a satisfied customer. A little big there, but I think we're just hitting some burrs. We do have some anodizing. Compensation for modifying brake bracket